Welcome to Sensible Health Solutions, the show where we simplify health and wellness. Join your hosts, Hallie Fields and Dr. Scott Luper, as they share practical tips and expert insight to help you navigate common ailments, nutrition, and overall well-being. Tune in for straightforward advice that empowers you to live a healthier life.
Hi, Dr. Luper. How are you?
Hello, Haley. I'm doing great.
Good. Well, something we haven't discussed yet on the show, which I think is a pretty broad topic and it impacts a lot of people out there, would be the different types of cancers that we see a lot of in the clinic, in your practice. I think that maybe starting out with leukemia would be best.
Good. Let's do that. So, as you know, this is a general practice. I'm a general doctor. I treat, everybody and everything. But as the years have gone on, I specialize more and more in actually treating cancer. Not so much doing the treatment myself. We work with oncologists here in town that do the actual treatments, also radiation oncologists and so various people. But my job is to keep people healthy so that they could go through the full course of treatment. And occasionally, when there is no good chemotherapy, figure out ways to get people better in spite of the fact that the chemotherapy or radiation doesn't work. But the vast majority of cases, almost everybody, is going to be getting treatment from someone else the same time they're getting treatment here.
Right. So you kind of work in conjunction with their radiation oncologist or oncologist and provide support for their body, make sure that they're eating enough, taking the adequate supplements so that their body is able to undergo the chemotherapy or radiation.
Exactly. So lots of times people can't do their treatment because they get so sick. They get horrible diarrhea and they just literally have to quit, or they get some horrible rash, or they get some horrible side effect. They swell up. We've seen that before. I'm thinking of a patient that we had go through all this just recently. And they pulled her off the chemo, and it took a while for things to calm down, but we were able to do stuff to help speed that recovery. And also now that she started a new chemo, we got ideas of how to stabilize her system, her immune system, so it won't react so much. And so far, she's not getting any reaction whatsoever. She's doing great. Energy's doing better. She's the best she's done in years right now, based on the stuff that we're doing. And it's not like it's rocket science, except for you think the oncologist would just do all this stuff, but they don't. They can't.
No, they're so busy doing and working their wheelhouse that anything outside is just too much. Not one person can provide all of the needs.
Yeah. Okay, so leukemia is blood cancer. It's cancer of white blood cells. And what happens is the white blood cells don't grow right. They tend to linger. Now, let me tell you how the system should work. Because we make new cells every day, new white blood cells every single day. Those white blood cells come out of stem cells that live in our bone marrow, and they divide and they mature in the bone marrow. And when they're ready, they get into the bloodstream, they float around for a few days or weeks or years, as the case may be, and then they interact with stuff as necessity demands. Mm-hmm. And the ones that hang around for a few days eventually die. Mm-hmm. They commit suicide, and a new batch of white blood cells come. Mm-hmm. And that's how it's supposed to work. There's two main categories of white blood cells. There's white blood cells that fight viruses. Those are known as lymphocytes. They're B cells and T cells. Lots of subcategories in those. And this is a gross oversimplification because they do all kinds of stuff. They help regulate the immune system. They do lots of things for us, but they're the main soldiers in the fight against viruses. And then there's granulocytes, and those fight against bacterial infections and parasites and stuff like that. And they're called granulocytes because if you look at these cells under a microscope, they're full of granules. Mm. They're actually quite beautiful. Once you stain these cells, they have these what are known as vacuoles. They're little pockets of poison, mm-hmm. and there's thousands of them, and they pile up inside the cell, and they stain beautiful colors. So they just like glow, like a little sack full of rubies is what it looks like. And these little rubies are very powerful poison, and when the body needs to kill something, it sends one of these cells close in, and the little packets of poison come up against the membrane, meld with the membrane, and pop. The membrane just combines, and it empties the sac, and so they go pop, 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 and send this little cloud of death.
Right.
And it kills whatever is close by.
Okay.
Which is great. It's a great system. Now, if there's any normal unaffected cells or normal stuff, yeah, those are collateral damage. They go down as well
Yeah,
as
but
the
your
bad
body's
stuff.
generating so many else that it doesn't really count for loss.
Take one for the team.
Yep. Yep.
And they also kill themselves in the process of doing this.
Okay.
So this is the normal system. You have these lymphocytes and you have these granulocytes.
Okay. But what goes
They're
wrong?
also called myelocytes. There's too many names. The names are all mixed up. But when we look at the leukemia, there are myelocytic leukemias and there's lymphocytic leukemias.
Okay.
All right. So the general, let's get to general categories of leukemias out. If it's a kind of leukemia, actually let's keep it simple. If it's a kind of leukemia that kills you fast, it's called acute.
Yes.
And you get sick and you feel horrible and you go, what is going on? You go to the doctor, they see your white blood cell count is skyrocketing high in the thousands or hundreds of thousands, and you have acute leukemia.
Okay.
Okay? This is a bad thing to get. In the olden days, it was an absolute death sentence. I mean, you were just going to die of this. There's no stopping it.
0% chance.
Yeah, 0% chance of survival. Those bad days are gone. Now the chances of surviving acute leukemia is very good. If you're a kid, it runs in the 90 percentile. If you're an adult, depending on what kind you have and how developed it is, it may be in the 90 percentile, it may be in the 40 percentile, depending on the situation. Still, not bad. You got a decent chance. Now, on the other hand, there are chronic leukemias. Those are slow. They take years to develop.
Are those diagnosed pretty soon after symptoms or later
not necessarily.
after symptoms?
That's a good question. Because usually it's symptoms that drive you in to go to the doctor.
Right, but if you're chronic, then is it something that you kind of just have learned to suffer with and live with?
No. Most of the time it's found incidental. Now,
Okay.
if you never go to the doctor, and there are those people, eventually you're going to get sick enough to say, I have to go to the doctor. And you go to the doctor, and again, just like the acute situation, your white blood cell count will be astronomically high. You'll be anemic.
Mm-hmm.
And I'll say why here in a bit. But there's a bunch of stuff that'll show up, and then they could see based on the blood tests whether you have anemia, or whether you have a leukemia or not. Now, for most people who go to the doctor regularly, it'll be picked up as an incidental, because the white blood cell count's going to go high for no reason, then no obvious reason. You don't have an infection or something like that, and then they'll start working it up. Once they actually look at those cells and analyze them, you can tell that they're leukemia based on what they look like and based on what the proteins that coat them are. There's a cell analysis that'll take place. Once you get the cell analysis, you know exactly what kind of leukemia that you have. Okay? Now, what would make you think you had leukemia aside from just happening to finding it by accident on a blood test? It would be that you felt funny. Not ha-ha funny, bad funny. You'd feel mostly tired is what it is. Now you think about what those white blood cells do is they have those little packets of poison in them, and they release those and they generate a fever, and they generate like getting flu, you get
Body
achy,
aches.
and you get, punky, don't want to get up and do anything, and then it kind of, you'll flare, and then it kind of clears up a little bit, and then you'll flare, and then it clears up a little bit, and that kind of thing. Like, I've been sick 3 times in the last, month and a half. I need to go and figure out what the heck is going on. And you go to the doctor, and then they run the test, and bingo, there it is. So you feel like that. If you're wondering, I wonder if I have leukemia, you could tell because I feel like I have the flu for no good reason. And again is what I have it, yeah. Night sweats are another common one that'll show up. Muscle aches, I don't know if I mentioned that specifically, that'll show up. And then anemia, I mentioned that earlier. Now, anemia is not obvious why you'd have anemia. I mean, it's white blood cells.
Yeah, not red blood cells.
Anemia is red blood cells. What's the connection there? And the connection is those white blood cells, since they are piling up, the problem with them, with all cancer, is you make new cells, but they don't die. They don't do what they're supposed to do. They just accumulate. And so they start taking up real estate. They start being where they shouldn't be. And these white blood cells start off in bone marrow, and so they largely hang out in bone marrow, and they fill your bone marrow up. They take it over. So now their bone marrow used to be the place where you made blood, like red blood cells. It doesn't happen there anymore because now it's been taken over to just do white blood cells only. So your white blood cell count will shoot up astronomically, and your red blood cell count will go down because your body can't make enough red blood cells because there's not enough area for that manufacture to take place. All the factories that make red blood cells have been taken over by the white blood cell people. Okay, there it is.
Okay.
That's how it goes. So what we want to do is we want to get some sense of treatment here. And I mentioned already that the acute leukemias, the ones that are fast, those are the ones that are easier to treat.
Because it's more of a clearer path of what they need to do.
No, your question is exactly right. Why?
Yeah.
Why are they easier to treat? The reason why is because the cells are more different than normal cells. The cells are younger, more primitive, literally more different from an actual functional white blood cell. Functional white blood cells have a certain characteristic, they have a certain personality, depending on what kind they have. And they do their normal thing. Now, the chronic leukemia is closer to those normal cells. And the acute leukemia is further away from those normal cells. So the further away the cell type is, the easier it is to have you take something that will specifically kill that kind of cell. Because with cancer, you need to kill the cells or have them kill themselves. Either you kill them or you stimulate them to commit suicide. And that's the problem. They're piled up. There's too many of them. So we need less or none.
Yep.
We can go none. Let's do none. Now, with acute leukemia, you can go all the way to none. And if there's any cells that are still making regular cells, you still have the regular functional cells, and you lose the leukemia cells, and they'll look at you. You're cured. You're fine. You don't need anything else. You just knocked out the broken cells.
How do they pinpoint the broken cells versus the functional cells?
Yeah, that experience. That's a good question too. It's experience over time. Some smart oncologist guys got an idea, knowing what they know about white blood cells. For example, let me give you an idea. Mustard gas. The stuff they were killing soldiers with in World War I.
Yeah.
Turns out one of the things it has an affinity for is to kill your white blood cells.
Okay.
So you think, well, why don't we poison people slightly with mustard gas and then see what happens to their white blood cells? Because it kills white blood cells, we kill a bunch of white blood cells. Suddenly there's less white blood cells, we get the white blood cell count to go down, and now people are doing better. And it worked. Seriously, it worked.
They weren't gassing patients out, though. They were administering it.
Nobody really wants to get gas. So can we make this into a pill or an injection?
Yeah. And
the answer is yes.
Okay.
And also, do we have to use the whole mustard gas or just a piece of it? And the answer is just a piece.
Yeah.
So bundastamine, I'm sorry, I'm not pronouncing the name right. Because the oncologists, there's so many big names that it's just a variety of mustard gas. Worked for this.
Okay.
And it works for, interesting thing, bundastamine is useful to treat more or less a wide variety of leukemias and lymphomas too. Okay. Both the chronic and the acute. So if you just got too many white blood cells, you do bundastamine and it knocks the white blood cells out. And look at you, you're doing great. Now here's the trick of it. The closer is your cancer cells to your real cells, the harder it is to differentiate between the cancer cells and the real cells. Because eventually they're the same cells.
The closer they are in proximity?
No, in type.
In type, okay.
They have a certain flavor.
Like
they have
the
a certain
chronic
character.
and the regular cells would be difficult to differentiate.
So you're starting to kill the cancerous cells. There's going to be some some spillover in killing normal cells.
Mm-hmm.
Now, if that difference is very far apart, it's easier to kill the cancer cells and spare the normal cells.
Your
If
good
they're
cells.
really close together, it's impossible.
Okay.
You killing the cancer cells, you killing the normal cells, you killing everything.
Mm-hmm.
And now you're in a jam because you can't live without white blood cells, not for long,
Right.
because if you'll get an infection. Oh, by the way, that's another one of the symptoms I forgot to mention. When you get leukemia or lymphoma, your immune system quits working, particularly with leukemia, and it shows up as an infection that won't go away.
Okay.
Okay?
Okay.
It's an
More so
infection.
the case with chronic leukemia that goes undetected.
Both.
Okay.
Both. But more so with the acute. It's more famous for having that be what happens. Now, again, these are different because now there's treatment. And the treatment's not only chemotherapy. You could also use radiation. And let me speak to a little bit why the radiation works. If you damage these already damaged cells, they have a damage to their DNA. There's a reason why they're cancerous, or for some reason. A lot of times you don't understand why people get leukemia. We think maybe it runs in families, but the research basically shows that it doesn't. Now, we do know that people got more leukemia following Hiroshima when they got exposed to radiation. Both leukemia and lymphoma numbers went up in the population that got exposed.
Mm-hmm.
And so it doesn't seem to be radiation itself. Something's affecting the cell lines, the white blood cell lines. It could be that they're getting viruses, and certainly in some cases they are. They found the viruses that are causing the DNA damage. But most of the time, we don't know what's causing this damage, but there is damage.
Okay.
Without a doubt, 100%, there's damage. Now, all of our cells have the ability to sense and either correct or kill cells that have been damaged.
Yes.
Now, this happens every day.
Uh-huh.
There's radiation from space and x-rays and CT scans
Free
or whatever it is.
radicals,
All kinds of stuff.
all over.
Damage our DNA. And so our body, the cells particularly, can sense that there's this damage here. And the protein that does this most is called the P53 protein. P53 protein senses the damage, slows down the metabolism of the cell, the reproduction of the cell, and then either fixes the cell and it comes out normal, or decides it's not fixable and then causes the cell to commit suicide. Now, in order for cancer to become cancerous, this has to break.
Yeah, so is there a breakdown in the body's ability to produce that P53
Not the
protein?
body's ability, the cancer's ability.
Okay.
So if the cancer can't make P53, or the P53 it has won't work because it's been mutated, then there's nothing to stop the cancer. And for a lot of cancers, that is actually the problem. That is a central problem to cancer.
And is there anything to treat specifically that problem?
Yes, and the way to treat that problem is to use radiation.
Okay.
Because what radiation does, it'll further damage the cells. So the P53 is damaged, but maybe it's not broken all the way. It's just sticky. You take a stick and you whack it on the side, and suddenly it turns on. It does what it needs to do. It needs to be whacked, right? We need to stimulate the P53 to work better. One of the ways to do that is chemo, and some chemos work by doing that. They do other things as well. Radiation works by stimulating the P53. That's what it does, more than anything. That's its main thing. And it works great unless the radiation, because it's causing damage to the cell, just happens to damage the P53 protein making part of the cell, the DNA that codes for P53 protein. Once that happens and that cell doesn't die, now you have super cancer. Now that cancer cannot be killed by radiation. And so what radiation will do is it'll kill the vast majority, 99.999% of the cells in a tumor, and then the rare cell that it breaks exactly the right way, that breaks the self-destruct program, that one continues to grow, and then the next time you get radiation, it doesn't work. You have what's known as hardened cancer. A common sense, you'd think, well, it worked the first time, why wouldn't it work the second time? It should work fine. Normal people could never see any reason why, but now that I've explained it to you, and y'all listening here, is that the self-destruct program itself becomes broken, and now you can't kill the cell. Now, you give it enough radiation, you will be able to cook it.
Yeah.
You will absolutely kill it, and you will kill the patient at the same time.
Yeah.
because there's no difference between the cancer cells and
Do
regular
patients
cells.
go through kind of a treatment where they first get chemotherapy and then get radiation and kind of alternate?
Yeah, it depends on the cancer. Some cancers are very sensitive to radiation, and you can cure people using radiation alone. Hodgkin's lymphoma, early stage Hodgkin's lymphoma, radiation is all you need. You just do radiation, you cook the lymph node that's affected, and then you're done. That's it, you're cured. Now, leukemia, not so much. Some radiation can be helpful, but mostly it's chemo. The real breakthroughs in the treatment of leukemia have been in chemotherapy.
Okay.
We can speak more to that.
Can you speak a little bit on how you help support these different treatments with what you provide in our naturopathic setting?
Excellent. That's a great question. So some of the common side effects of these treatments are digestive problems. People get diarrhea mostly. They also get constipation. They get nausea, horrible nausea. They'll get vomiting. Those are the big ones, the digestive ones. Yeah, there's a bunch of other stuff too, but let's focus on the digestive complaints. The reason why people are getting digestive complaints is because the chemotherapy agents target fast-growing cells that have a fast metabolism and have quick double times. That is, they go from 1 cell to 2, 2 to 4, 4 to 8, that kind of thing. And so the cells in our body that have the fastest doubling times, that act the most like cancer, are the cells that line our digestive system. Now, we grow a new lining to our digestive system every 3 days. Mm-hmm. That's how fast the turnover is. So about a third of the protein that you absorb every day is broken down from the lining of your digestive system. So there's a lot of cellular turnover going on. So if you do chemotherapy that damages those cells and slows the replacement of those cells, what you get is a thinner, weaker, more damageable, more friable lining to your digestive system. You become a delicate.
That isn't able to absorb nutrients very well.
Yeah, exactly. Exactly what it is. And the reason why people are getting nausea and vomiting and diarrhea is because the body's normal defense mechanisms. When you get a digestive system that's super sensitive, super delicate, and you eat something and it's like your instinct is this is bad, whoop, you vomit it up. Or deeper down, this is bad, and your body just basically, whoa, let it go, shh, then it falls. Mm-hmm. It goes on right on through you. And now you're losing weight, you're getting weak, you're not long to live on the planet with your digestive system broken down. And so what an oncologist will have to do is they'll have to stop the treatment. Now, stopping treatment doesn't mean the treatment won't work, but the chances of it working goes down. If you can finish out the treatment, maybe even do a little extra because you're doing such great shape, the more treatment you can endure, the better chance it has of working, the better chance it has of killing the cancer cells completely. Mm-hmm. Not just most of them, but all of them. Mm-hmm. Mm-hmm. So if you cut it short, some people are lucky, might have got them all, but no, the chances are is low and not good at all in any way that you're going to be able to get them all. And so it's super, super, super important to treat people in such a way that they can tolerate the treatment, the chemotherapy treatment. So how do we keep people from vomiting and getting diarrhea and having their digestive system fall apart?
We support their digestive lining. We support the deterioration, and we help them in those ways.
Yeah, so there's some things you can do in certain situations. There's things that you can't do. And I'm going to give you a weird example. Actually, I'm going to do normal, easy stuff first and save the weird example for a little bit. The normal, easy stuff is, if we can simply assist in the digestion of food, break it down into amino acids and basic components, carbohydrates and just basic stuff.
So give them a digestive enzyme.
There you go.
Okay.
You give people digestive enzymes, and now their digestive system works better.
Okay, what's the next step if that first line doesn't work?
So what we can do is we can give them bitters.
Okay.
And what the bitters will do is they'll stimulate their digestive system to make
producing more acid.
Not only acid, but digestive enzymes, more peristalsis. The whole kit and caboodle goes up.
So we give it bitters in the form of herbs.
Yes.
So some of the herbs
that we use. Mm-hmm. Berberine is a decent bitter. Gentian is a decent bitter. I mean, the list goes on and on. There's a zillion of them. So let's talk about why bitters work. And we've done a show on this, but not everybody's seen the show. What bitters do is they stimulate your digestive system because bitter is an indication that the thing you just ate is poison. Mm-hmm. Now, we don't give anybody any poison. There's no poison in these bitters at all. But our body doesn't know that. Mm-hmm. It assumes that this bitter flavor is in fact poison.
Right.
Now, just because it's poison doesn't mean it's going to kill you. Maybe it's a very mild poison, and it's mixed with a lot of good calories. Mm-hmm. So what your body wants to do is break down the poison and absorb all the calories. Mm-hmm. You don't want to necessarily just vomit it up. You want to get what you can out of it. You went through the trouble of eating the stuff. Let's see if we can extract some.
So would you take the meal first and then the bitters after?
No,
or
you do the bitters first,
to
the meal
produce
after.
The enzymes to then fill the meal
So
in?
there's a reflex of when your body tastes bitter to make more digestive enzymes to break the poison down, to digest the poison. It's not poison anymore if you can break it down. And so a lot of these plant poisons can be digested. And so that's what our body does. It breaks them down, and now they're not poison anymore. So our body can tolerate a small amount of toxins in our food by digesting them up. Now, in nature, if we're going out and eating nuts and berries off the bushes, a lot of times we're going to come across toxic elements because the plants make them because they don't want to get eaten.
Right.
Now, in our diet, what we've done is select for those foods that have the least amount of toxins in them. They're the least bitter. Mm-hmm. And so we don't eat bitter anymore as a society.
No.
We figured out how just to get rid of them altogether. But in the old days, that wasn't the case. Mm. Now, when you were eating a salad in the old days, it still had the bitters in it.
Right, because some of the leaves you picked looked like, regular leaves, but they were bitter.
Well, all lettuces were bitter because they didn't want to be eaten by the so the plants made these bitters.
Yeah.
And now over time you find the mutated plants that don't taste bitter. Mm-hmm. Butter leaf lettuce, right?
Right.
And so we're going to grow more of this stuff and less of that other stuff. Now, occasionally people get a wild hair and they want to eat something that's bitter.
Arugula.
So they have arugula, right? Mm-hmm. Or rocket, right? They still exist. The Belgian endives are bitter too.
Dandelion root.
Yeah, they still exist in our world
of course.
As a novelty now. Now, what we do is we take those bitters, make it into a concoction, give it to people, and we all still have the reflex.
Yep.
You get the bitters, and suddenly your digestive system's working better. And you don't need less stomach acid. You need more stomach acid to break your food down. You get better digestion, you get better nutrition, and cancer patients tolerate their chemotherapy better based on the bitters they get.
And do you recommend anything to support the overproduction of the enzymes? Does that sometimes weaken the lining too? So is there something else? Okay.
Good question. No. The system's set up to have the right coatings that keep the enzymes from breaking down the lining of the digestive system. Now, there's another trick that we can do if we absolutely need to, and that's glutamine. Glutamine's an amino acid that's used preferentially by the cells that line the digestive system, the upper part of the digestive system, the small intestine in particular. Glutamine works beautifully to treat this. So you get a window of opportunity where you can use glutamine pretty much with impunity and not grow cancer. But if you put patients on it long term, eventually it's going to start growing their cancer.
Okay.
So it's a two-edged sword there. You can help the patient, but you can also eventually help the cancer. So it is with all these treatments. If you're going to make somebody perfectly healthy to the max, you're also coddling their cancer, and then they're not going to survive necessarily. So you got to figure out what the cancer's sensitive to more than the person, and then that's what you do. That's what the reason why chemo makes us sick is not because it's designed to make us sick, it's designed to kill the cancer. It just so happens we're similar to the cancer. Those used to be our cells right before they mutated,
yeah.
And so there's some blow-by effect that we pick up.
Okay, well, I think this episode we're out of time,
Okay.
but we'll pick back up, I'm sure, on the next episode.
All right, Haley, excellent. Good questions.
Thank you.
Thanks for tuning in to another episode of Sensible Health Solutions. We hope you found today's discussion enlightening and packed with practical tips to enhance your wellness journey. Remember, small changes can lead to big results. If you enjoyed the episode, don't forget to subscribe and leave us a review on your favorite podcast platform. Your feedback helps us bring you the best content possible. Stay connected with us on social media for more health insights and updates. You can find us at Sensible Health Solutions across all social platforms. Until next time, stay sensible and stay healthy. This content is for informational purposes only and is not a substitute for professional medical advice, diagnosis, or treatment. Seek medical advice from a healthcare professional for any medical conditions.